Hey everyone, have part 2 video for you for chapter 13, lesson 2. This is pretty much continuing off of what we started with the graphing. So remember that we're now just graphing angles on a regular graph. And so it's a little bit different because we're not using hash marks too much anymore, but we're kind of treating it as a clock and a circle, right? So we start at 0 and it goes counterclockwise. Each section is 90 degrees. And so when you get all the way back, you get to 360, which we now know is a full circle. And of course, it can go on forever. So, this, if you kept going, this would be 450, 540, 630, and 720, right? So you can keep going on forever. Not a big deal. It should be intuitive, right? So just add the 90 whenever you need to, or just figure out the multiples when you need to. So the last part of this is a little bit different. What ends up happening is, so we basically now we have to include what we know about triangles into this graphing business. So what ends up happening is, of course, whenever you start drawing an angle, you start on the initial side, which is always at 0. And then you're going to have a terminal side or the ending side somewhere, right? Based on whatever is told to you. So what you'll start to see being asked is, well, here's my angle, right? Because you do whatever angle, you start here and then you go all the way until you stop. Now I have an angle bigger than 90, which is fine. And now you're basically asked, well, how do I figure out those trigonometric functions out of that? So remember sine, cosine, tangent. Now, the only way to do that is to have a triangle, right? These functions work only if you have a triangle. And so what we'll have to do with this is now create triangles out of the angles of rotation. So as you can see in this example, how do we make a triangle? Well, in this particular example, what you'll end up doing is, remember the reference angle? So the reference angle is the angle you make where you just go to the nearest part of the x-axis. So the x-axis is right here. So we're just going to go down, this in yellow. We're just going to go down to here, okay? That's the reference angle. You're basically going to make a triangle with that, okay? So this was theta. And now to make a triangle with this, we're just going to connect. We just want to pretend, and assume we're going to draw a straight line from this now x-axis all the way up to this line here. And if we draw a straight line, that means we're going to create a right angle here, which is exactly what we want. So you're always just going to draw this straight line, and that'll create the right angle. And now you have a triangle to work with, okay? So everything that you learned about triangles now applies to this. On this graph, which is kind of cool. And how you do, how you'll calculate those sine, cosine, tangent is by using the x and y values. So now we're going to bring in the x and y values. So it's just like a typical graph, right? Now, let's say this is 4, right? So I counted, this is -4 actually, okay? X equals -4. And then, so we're just using points now to help us figure out. And this is at 3, okay? So this ending point here on the triangle right there is at -4, 3, okay? So that really helps us, because if you draw this triangle out by itself without the graph and stuff, it looks something like this, right? We said that the x goes all the way, the triangle starts if you go down to -4. So this is -4, okay? You keep the signs for this. You always keep the signs. And so we said that this point here, this tip, went up to +3. So that means this side is 3. Now look at that, right? Now we have a triangle to work with 2 sides, and the only missing side is across from the right angle, which is the hypotenuse. How do we figure out the length of the hypotenuse? Easy. Use the Pythagorean Theorem, 3 squared plus -4 squared. So this is always going to be positive, so that's not a big deal. And as you know, this is a 3, or hopefully, if you remember, this is a 3, 4, 5 special, triple. So 9 plus 16 gives us 25. So that means CS equal 5. Okay. Awesome. That means that the hypotenuse ended up being 5. And now what you'll do is just use these 3 numbers for sine, cosine, tangent, and pretend that your angle was this one here, starting from the center. So you see how this angle here, right here, is the same as this one here in our actual graph. And so you're going to do it based on this angle. Okay, so if we do that, where can I write this? Let's get rid of some of this here. So that means the sine of theta is opposite over hypotenuse. So this is just 3 over 5. Okay. And then the cosine is adjacent. Well, that's -4. We do keep the signs. Okay, we do keep the signs because sine, cosine, tangent are allowed to be negative. -4 over 5. Right. And then tangent. Do that up here. Tangent is opposite over adjacent is going to be 3 over -4. So -3/4, basically. That's that. So yeah, so basically, what just happened is we took this point here where we ended up drawing the triangle from, which was -4, 3, XY coordinate plane. And then 3 becomes, the Y value is 3, which becomes your opposite side, right? So 3 became our opposite side here, which we use for sine and tangent. And then the -4 became the adjacent side, which was the X value. Okay. And this is all explained in your book too. So read through that to help give a little bit more clarity to this. But we're just basically using like an XY value now to help create a triangle, and then therefore learn and calculate a bunch of sine, cosine, tangent functions just by hand, which is really cool. So let's do an example actually. So let's say I had a graph. Of course we have 0 and then 90, 180, 270, right? And 360. So the wording is like, you have a point. Let's say this is a point at the terminal side of some theta, right? And that's what your homework says. Is it just gives you a point and it says this is where the point is on the terminal side of an angle. Remember, the initial side starts at 0, and then the terminal side is going to be 4, -5. So let's actually graph 4, -5 first. 1, 2, 3, 4. 1, 2, 3, 4, 5. So that point is right here somewhere. Okay. So that means the terminal side, which is the side you end on, goes all the way around. And then if I draw to this point, boom. Mostly got it. So the angle goes all the way around there past 270. And now, we have to find sine, cosine, tangent. And you basically do this the same way. We have to make a triangle, right? You have to make a triangle to get sine, cosine, tangent. So how do we make a triangle? Well, we have the 2 sides already on this drawing. So now you just take your dot here where the angle ended, and you just draw a straight line all the way down to the X axis, which now creates this triangle where this is the right angle. Okay. Now, what are the lengths of that triangle? So let's draw it. Let's draw it off to the side here. This is our triangle. Boom, boom, boom. Well, what are the lengths? Well, that's not too straight. Sorry about that. Let's go here, here, here. There we go. Well, the point was at 4, -5. So this x, this side right here, right there is 4. Okay, 4. It went all the way down to -5. So that means this long side here, the y value, this is -5. And the only side we don't know, of course, is the hypotenuse. So the x value becomes one side, the y value becomes the other side, and then you use those two in the Pythagorean theorem to find the hypotenuse. So let's do that. Let me draw all this off to the side. So let me just redraw the triangle here on its own without the graph. So -5, and then 4, and then our question mark. So 4 squared plus -5 squared equals c squared. This ends up being 16, 25, and this is going to be 41. So c equals square root of 41. Okay, not a nice number, but that's okay. So c equals square root of 41. So let's fill that in here. Our hypotenuse is square root of 41. And again, now we're doing sine, cosine, tangent, where the angle is this one coming from the center. Okay, so if you, so let me kind of redraw this here. Just bear with me for a sec. Okay, so we had 4, -5. So our side went all the way here to here, right? And then we drew a straight line all the way down to this point to make our right triangle. The angle we're using is, of course, the one in the center here, okay? So in our triangle picture, it's this one, right? Basically, yeah, cool. Basically, associate where, and you'll start to see this, where the y value is what is sine, and the x value is cosine, okay? Because it's the adjacent side. And the y value is sine because it's the opposite side, all right? So the sine of that, the opposite side is the y value, which is -5 over square root of 41. And then, you get rid of the square root, but let's just write them out for now. The cosine is the x value, which was 4. Remember, our point up here was 4, -5. So you can start to, you might be able to get in the hang of this where you don't even need to draw anymore. You just use the numbers that you see. But the cosine value is the x value, the adjacent side over the hypotenuse. And then tangent is, of course, our y value over our x value, which is the opposite side, which is -5 over the x value, okay? These are, of course, you would have to simplify out or change just because you don't have the radical in the denominator, but that's pretty much that. And so what this boils down to, and sort of the quick way to think about this, is without drawing, right? You basically have sine is going to be y over hypotenuse. Okay, cosine is the x over the hypotenuse. And the hypotenuse you have to figure out first, right? Like we did in the other examples. And then tangent is y over x, does not use the hypotenuse, as we know. Okay, so if you just look at it like that, this is in your book too. This is kind of the shortcut method to do it. But as long as you're understanding at least how the graph works, because that's really important to you, especially later on. And of course, the x and y values come from where the point is, right? So x equals 4, y equals -5 in this case. So you get a few problems like that for your homework. Yeah, let me know if you have any questions. Again, I know we're kind of we're going a little bit fast through this. The year is ending, and we do have some stuff we want to finish. But yeah, just let me know if you have any questions. Of course, happy to explain more. We have a call tomorrow too, so please join the call for some extra explanation and practice. And then yeah, good luck with everything. Thanks. Bye.